Hello friends and welcome back to the channel. This is Conic section part 3. In this part we're going to discuss how conic section is recognized or what is the general equation of conic. So without wasting any time, let's get started. In the previous two lectures we have seen the equation of conic and some important terms related to conic. But now, in this part, we're going to see what is the general equation of conic. That is, for a straight line, we know it is ax plus by plus c is equal to 0. But for conic, what is it? Let's find out. The general equation of conic is, which is represented by letter S, is equivalent to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So this is the general equation of conic. Knowing this is not a big task, but what is important is now what I will discuss. So first of all, we need to find out the discriminant of this equation. That is, which is represented by delta, which has the value equal to ABC plus 2FGH minus AF square minus BG square minus CH square, and this is the value of determinant. So based on determinant, we actually classify our conic. So this is the toughest part. So how do you remember it? The method to remember is little hilarious. That is, the value of discriminant is equal to so AHG, HBF, GFC will give you the value of determinant as follows. So let's find out how we can remember this. So remembering this for the first row is all hot girls. All hot girls having boyfriend go for coffee. So this is how you gonna remember this. The initial letters of all the words form the rows and columns of this discriminant. So all hot girls having boyfriend go for coffee. A simple way to remember it, and this will help you to find out the nature of conic or whether a conic is degenerate or non-degenerate conic. So we have learned how the discriminant is formed. So as I said before, now with the value of discriminant, we're gonna classify discriminant into two different types of conic. One is for the value when delta is not equal to 0. This case is for non-degenerate conic. So first of all, in this lecture, we're gonna learn what are non-degenerate conic. So this is the table for non-degenerate conic. These are the conditions which are necessary to find the nature of conic. That is AB minus h square. The dependency of AB minus h square gives out the value of or the nature of conic. You just need to learn AB minus h square term, and I'll give you a method to memorize these conditions. Since we know that for parabola E is equal to 1, the opposite of 1 is 0. So just equate AB minus h square to 0. For hyperbola, E is greater than 1. So greater sign has the opposite less than value. So AB minus h square is less than 0. And similarly, we have for ellipse E less than 1, AB minus h square greater than 0. And for circle, A is equal to B and H is equal to 0. Or you can say there is no xy term in the equation of circle, since we discussed before that the general equation of conic is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, where h was the coefficient of xy. So these are the four important conics which we're gonna discuss. Rectangular hyperbola is a subcase of hyperbola, and the condition for it is AB minus h square being less than 0 and also A plus B equal to 0. So these four, or we may say the fifth one as a subcase, so these four and the subcase makes non-degenerate conic. Or for delta being not equal to 0, we get non-degenerate conic, and these are the conditions for it. Degenerate conic would be discussed in the next lecture. So guys, this is it from this video. I hope you enjoyed it. This is Yojit Bhasin signing off. Thank you. Meet you in the next video.